Dear friends, let us understand what do you mean by indexing or indexed addressing. As we are aware that displacement addressing basically consists of relative addressing, base register addressing, and index addressing. So we will be going ahead and looking into this topic in depth with respect to the index addressing. Now, what do you mean by index addressing? It is used to access elements of an array which are stored in the consecutive location of memory. So you should understand that indexing or index addressing basically uses three components. One is called as the effective address, which is the component consisting of address and register indirect address. So EA is equal to A plus into bracket R. The address field A gives the main location where the contents are stored into the main memory, and R gives the displacement with respect to the base address. So how much the components are moved from one location to the another is being called as your register indirect addressing with the help of R. The displacement address can be specified directly in the instruction or to the given registers. Now for understanding this, let us understand this example. Move register R1, that is R1, comma bracket, base register BR plus 5, and 5 is being called as your offset index value. So first of all, let us understand what do you mean by offset. Offset can be defined, it is a value that is added to the base value to drive the actual value. Offset into file is simply the character location within that file, usually starting with 0. Now when you look at the syntax of this, it will indicate move RO bracket, starting address is base register BR plus the value 5. It is called as your R1, which is called as your offset index. Now what do you understand by auto indexing? Generally the indexing registers are used for iterative tasks. It is typically that there is a need to increment or decrement the index register after they are being referred. Now, first of all, try to understand why it is the need of incrementing or decrementing the auto indexing. So, incrementing or decrementing auto indexing becomes very important because it is responsible for the release of memory. So when we release the memory, what happens? The memory execution becomes faster, the processor execution becomes faster, and this is called as your auto indexing plays a very important task. Because there is a common operation, sometimes the system will automatically do this as a part of the instruction cycle. So because it is auto, it means that automatic, it starts indexing. It may be auto incrementing or it may start indexing by using the auto decrementing mode. Now what do you mean by auto increment? Let us look in this with the help of an example. If register R contains the address of the operand R, after accessing the operand, the content of register R is incremented to point to the next item into the list. So what do you understand by auto indexing? It is the effective address that is equal to address plus R, or effective address is equal to indirect register plus it may be an address or it may be a command. But here your indirect register R is the combination of indirect register R location plus 1. So if your location is 10, it will automatically get incremented to 1, that will be 11. Example, move R1, 1010. Starting memory location 1010 is stored in R1. Add AC bracket R1 plus. The content of 1010 ml are added to AC and the content of R1 is incremented by 1. Similarly, the example what we have seen, EA is equal to indirect register and the brackets are closed plus. So the content of register which are indirectly stored is automatically being incremented. If the value is not specified, it can be n sort of increment, n value you can consider. Auto decrement, we have used the plus sign in case of when we wanted to increment. Now when we want to decrement, it is in the form of minus. Auto decrement, the content of register specified in the instructions are decremented and these contents are then used as the effective address of the operand. After indexing uses decrement, it can be dissipated as follows. Here, you should be aware that if you are using auto decrement, the signal or sign should be minus. EA is equal to A minus bracket R. R indicates the indirect register, or EA is equal to minus bracket R. For calculating the value of R, you can consider indirect register is equal to the value what you get minus 1. So if the value of your memory location is 10, for example, it gets decremented by 1 and the value effective address becomes 9. Now the content of the register are to be decremented before used as the effective address. So add R1 comma minus R2. So here whatever value you get is being decremented and then it is being added to the value R1. So this is how your auto decrement mode takes place.